All right, everybody, Mr. Longo here, about to talk to you about exponential growth and decay. So the formula is y is equal to a times, in parentheses, 1 plus or minus r, all raised to the t power. Now, a is your initial amount of whatever it is we're talking about. T is going to be time. Your rate could be growth or decay depending on if it's positive or negative. So if it's exponential growth, it's going to be plus r. If it's exponential decay, it's going to be minus r. Okay? So what we're going to do is start with a brand new pond in the middle of a subdivision. And they're going to stock it with 200 fish. And they expect the population to increase at a rate of approximately 10% per year. So the first thing you're going to have to do whenever you are analyzing exponential growth and decay is to write an equation. So y is equal to our initial amount, which is 200 fish, and then times in parentheses we have 1, and then we have to decide if it's growth or decay. Well, it says the population is going to increase by 10%, so that's plus 10%. And you always do percent as a decimal. And then, of course, raised to the t power. That's your general equation. And then we can use that equation to predict the population of fish in any year. So how many fish are expected in 2 years? Now, if you think about this, 10% of 200 is 20 fish. So you're going to guess 240. And I'm going to show you why that's not going to work. And I'll explain it. So y is equal to 200 times, you can combine that if you want to now, you can call it 1.1, raised to the second power. So you just go to your calculator, 200 times 1.1, or you could do the 1 plus 0.1, it's up to you. Raised to second power, click enter, and you get 242. There are going to be 242 fish in the pond after 2 years. Now, why does that work? Well, you're right. 10% of 200 is 20 fish. So if we take 10%, we get 20 extra fish. So you think 220 after that first year. But then the second year, there's already 220 fish in that pond. So you would multiply that by 10% and you would get 22 more. That's why it becomes 242 fish and not just 240. So every year you redo the 10%. So the first year you take 10% of 200. The second year you take 10% of 220. So that's why the longer it goes, the more and more it's going to increase. It's not going to be constant of 20 fish per year. Okay? How many years until there are 300 fish? Well, that means you're just going to set it equal to 300. It is equal to 200 times 1.1 raised to the t power. So we have an issue here. You do not know how to solve an equation algebraically yet when your variable is the exponent. Now you're going to learn how to do that in this unit, but for right now you don't know how. So how would you predict it? Well, one thing that you've always had for yourself is a calculator, and we know all you have to do is set two equations equal to each other by putting 1 in y1 and 1 in y2. So in y1 you just type 300. And in y2, you just type your exponential growth equation, which is 200 times 1.1 raised to the x, because we can't type a t. And you're just going to click graph. Now, your graph might not look like mine because I've already adjusted my window so it fits. You would have to adjust yours. So you need to adjust your Y max so it's going to be at least 300. So you want to go a little bit more than that so you can see the intersection. And then just press second trace, which is the calculate menu. Number 5, which is the intersection. Click enter 3 times so you find the intersection of those two lines, and you get approximately 4.254 years. So you can just use your technology to find the answer for you. At the end of this unit, you will be able to solve that by hand. But for now, just use your graphing calculator. Okay? Now, very similar to exponential growth is exponential decay. The only difference is things are going to get smaller now. So everybody knows when you buy a car, it costs you a lot of money, but when you go to trade it in, it's not nearly worth as much because as you use it, it's not worth as much anymore because it's not brand new. So a new car, we're going to pretend costs $24,000 and it depreciates in value by 18% per year. So let's write an equation that represents that situation. Go ahead and give it a try. If you came up with y is equal to 24,000 times 1 minus 0.18 raised to the t, you are correct. The initial value is $24,000 and it depreciates, which means it's decaying by 18%, 0.18. And then we're just going to use it. What's it going to be worth in 5 years? Well, y is equal to 24,000 times, again, you can write 1 minus 0.18, or you can write 0.82 raised to the 5th power. So you just go to your calculator, 24,000 times 0.82 raised to the 5 years, and your car is worth approximately $897.76. So, you know, one of the things you'll learn about buying cars someday is the day you buy it, it's worth a certain amount of money. As soon as you drive it off a lot, it just went down by a certain percentage. And that's because it is no longer a new car. It's now a used car. All right? So that's it for this video on exponential growth and decay. This is Longo and I'm out. See you bye.